So good evening each and everyone. So I'm back again for another video. For this day I'm going to talk about the chapter 13 contains LAN configuration. For the LAN configuration, the wireless router, remote workers, small branch of offices and home networks often use a small office and home routers. These routers are sometimes called as integrated router because they typically include a switch for wired clients, a port for an internet connection, sometimes labeled as WAN, not ONE, and wireless components for wireless clients access as shown of the camera carriage in the okay. So let's study here the wireless router. So we're gonna talk about here the LAN configuration and connection by it. We're talking about the wireless router, just like it has such connection in the past chapter, the chapter 12 also deals in routers and wireless routers. So, as a quick review about wireless are those things that you can connect to the internet without using wire. That's it. Simple as that. Next one is the WLC topology. For the WLC topology, or it deals with the topology are an addressing scheme, a topology and addressing scheme Polygon addressing scheme of the use of videos and topic are shown in the figure and table. The access point AP and controller base AP opposed to an autonomous AP recall the controller base APs require no initial configuration and then often called lightweight APs. So it mostly like labs use the lightweight access point protocol LWAP to communicate with an one LAN controller or the WLC. It is WLC topology, the LAN controller. Controller-based APIs are useful in simulations and situations where APIs are required in the network. As more APIs are added, each AP is automatically configured and managed by the WLC. So it is said here that the wireless controller or the WLC controls the APIs. The what is APIs? APIs are the access points. It is being controlled by the wireless controller. And also, it said here the SNP and radius. For the SNP and radius in the figure, PC is a running simple network management protocol. SNP and remote authentication dial in user service radius server software. SNP is used to monitor the network. The network administrator wants the wireless LAN controller to forward all SNP log messages call drops to the SNP server. In addition, for LAN user authentication, the network administrator wants to use Radius server for authentication, authorization, and accounting the AAA services that like I've said in the past chapter that I've tackled already. Instead of entering public known pre-shared key to authenticate as they with WPA, user will enter their own username and password credentials. So it means of saving or sending a confidential files in some to someone or saving it to your account. So as and the most easiest way is to put their username and password credentials for them to enter those that or you to enter that network for them to save their confidential accounts. The credential will be verified by the Radius server. This way, individual user access can be tracked and audited if necessary, and user accounts can be added or modified from a central location. The Radius server is required for LANs that are using WPA Enterprise Authentication. But note, SNMP server and Radius server configuration is beyond the scope of. Yes, that's it. And the next is the troubleshooting approach. When we hear about troubleshooting, I've always remembered there was a problem within it because, like before, when I was surfing the internet, there's a when the internet is not really functioning well. It is said that there is a troubleshoot. Troubleshoot something when I mean, what is troubleshoot? By the root word trouble, there's a problem. There's a rage within the internet, or they just exaggerated the term that they use for the user to truly understand what is happening on the internet as well. For the troubleshooting approaches, network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. So before the because there are different kinds of problems, like what I've said, maybe small, maybe complex. When it comes to be complex, maybe it deals with the whole device itself. It deals with the hardware, the software, and the connectivity issue. But first, the troubleshooting is they will first check the or they will analyze first the hardware, then the software. Then before that, they will think or they will make a conclusion on how does the connectivity issues comes in with that problem, because it is the use of troubleshooting. Troubleshooting any sort of network problem should follow a systematic approach. A common and efficient troubleshooting methodology is based on the specific scientific method and can be broken in the six main steps. Six main steps. So these are the steps. Step one: identify the problem. Yes, you should identify the problem, because how come you do solve a problem without identifying it? The first step in the troubleshooting process is identify the problem. Well, tools can be used in this step. A conversation with the user is often very helpful. So, for example, the user, I am the technician and you are the user. I'm gonna first ask you what happened on your device, or what happened you click, or what happened there's any a what do you call this, a certain phenomena that you didn't even see but happened already, and it may lead for the device to be broken. Next one, establish a theory of problem causes. After you have talked to the user and identified the problem, you can try to establish a theory of probable causes. This step often yields more than a few approachable causes to the problem. So after identifying the problem, you should now establish a theory, because, for example, the mouse, for example, the CPU is not working with the monitor, or the CPU is not working with, yes, the monitor. May the user will tell you that, oh, because I found something on the wires that is broken, and that's it. I found something in the wire, and when the wire is broken, there is something that deals a connection within the computer, and you will check if it is connected in the computer and the CPU. If it is connected, there's a chance that is the cause of the problem. Next one is test the theory to determine the cause. And when you do make a theory, it is a theory. You're not very sure about it, but you are the right thing is you are guessing the problem, but you are have your guess on your problem. And by the means of that theory, you should test if it is really the means of the problem, really the problem is. They said that based on the probable causes, test your theories to determine which one of the cause is the problem. A technician will often apply a quick procedure to test and see if it solves the problem. If a quick procedure does not correct the problem, you might need to research the problem further to establish the exact. So sometimes the theory, because it is a theory, sometimes it fails. But there's always a but it is a trial and error process for the technician, and it is good also, because if you already know that there's not a problem, maybe there's something in the other more parts of your device. And next one, establish a plan of action to resolve the problem and implement the solution. It is really important. If you over After you have determined the exact cause of the problem, you should think about the solution of it, because what is the sense of knowing the problem without even even thinking about the solution for that certain problem? Okay. Next one is verify system functionality and implement preventive measures. After you have corrected the problem, verify full functionally and applicable implemented preventive measures. So after checking or after fixing, you have corrected the problem, you must check the whole device itself, because maybe if you have corrected the kind of problem, there's something that has been being affected on other parts of the system. So you should always put or implement a preventive measures after correcting it. And lastly, document findings, actions, and outcomes. In the final step of the troubleshooting, process, document your finding, actions, and outcomes. This is very important for future reference. So, for example, that kind of problem is you just what we call this you just um, not think about it, but you just have faced with it at first time, that kind of problem, and you can put a documentation and a certain overview about that thing that you have done, and also the things that you have done to correct it, for that the other technicians that may have that kind of problem, it may help, it may really help the other technicians to deal with their problem, and that's very important. And to assess the problem, determine how many devices on the network are experiencing the problem. If there is a problem with one device on the network, start the troubleshooting process at that device. If there's a problem with all devices on the network, start the troubleshooting process at the device where all devices are connected. You should develop a logical and consistent method for diagnosing network problems by eliminating one problem at that time. So it is said that if there's a problem only on one device, just go and fix that one device. But if there is so many devices, for example, 10 devices, 10 PCs are not working well, or there's no internet there, so goes where the 10 pieces are connected, and then maybe the problem is there because how come that the other piece will not work? How come that all pieces will not work if there's no problem in the one where it's connected with the PCs? And that's great. I hope that you've learned something in this topic, in this chapter 13 contents, LAN configuration. So this LAN configuration more deals on about different kinds of wireless and how do you deal if there's a certain problem within it. Because, for example, the troubleshooting, it was really great. You know those steps that it is being there in the Cisco in the no, yeah in the NetAcad in this chapter 13, it is very good. It is very helpful for those technicians who are enhancing their knowledge on how to prevent or on how to correct some or problem within a device. It is really good to have it. And I hope that you've learned something. Those are the contents of the LAN configuration chapter 13 of the CNNA one of the networking one. And thank you so much for giving your time and effort for watching this video. Thank you so much and good night.